Hello everyone, I'm Adam. So in this problem, what we have is for the vector with initial point at coordinates 3, 2, 0 and terminal point 4, 1, 6, we're going to be finding these three things. And number one, we're going to find the component form of the vector v. 2, the magnitude of the vector v. And 3, we'll find a unit vector in the direction of the vector v. So let's start with number one, where we want to find the component form of the vector v. Now, recall in general, for some vector v with, say, some initial point, which we'll call P, and coordinates P1, P2, and P3, and some terminal point, call it Q, with coordinates Q1, Q2, and say Q3. So the component form of the vector v, which will be the same here in 3 dimensions as it was in 2 dimensions, will have components, say v1, same meaning having components, obviously there'll be more dimensions, v1, v2, and v3. And how we find these components is again the same as it was last time, is we're going to take the component-wise subtraction from our terminal point and our initial point. So the component v1 will be found by q1 minus p1. v2 will be q2 minus p2. And v3 will be q3 minus p3. So putting this together, the component form is going to be, so our q1, which will be 4, minus our p1, or 3, then our q2, 1, minus p2, 2, and lastly, q3, which is 6, minus our p3, which is 0. And so that gives us the component form of the vector. 4 minus 3 is 1, 1 minus 2, negative 1, and 6 minus 0, we have 6. Okay, so that's part one. Part two, we want to find the magnitude of this vector v. So for 2, we want to find the magnitude of the vector v, which again, even in 3 dimensions, the formula is very similar. It's the square root of the sums of squares of the components. So the magnitude is going to be v1 squared plus v2 squared plus v3 squared. And that's equal to the square root of our components here. So v1, or 1 squared, plus v2, negative 1 squared, and plus v3, right, or 6 squared. So we get 1 squared, which is 1, negative 1 squared is 1, plus 6 squared, which is 36. And that's the square root of 38. And if we look at that, that can't be simplified by taking out any more roots, so we'll leave it like that. So our magnitude of the vector v is the square root of 38. And lastly, what we're looking to do is find the unit vector in the direction of v. So finding a unit vector, right, in the direction of v, starting out looks like the same formula that we had in the 2-dimensional case, 1 over the magnitude of v times the direction of v. Times the vector v. So that's 1 over our magnitude, or 1 over the square root of 38 times our vector v in its component form, 1, negative 1, and 6. Now, sometimes it's common to leave the answer in this form, where we're leaving the scalar 1 over the magnitude on the outside, but we can also multiply through that by multiplying each component of the vector with the scalar, or 1 over our magnitude. So 1 times 1 over square root of 38 gives us 1 over square root of 38. Negative 1 times 1 over square root of 38 negative 1 over the square root of 38. And lastly, 6 times 1 over the square root of 38, or 6 over the square root of 38. So both of these together would be acceptable answers as far as the unit vector in the direction of v. Thank you very much.